Good morning, dear student. Today I am discuss error function of Laplace transformation. I am also discussing in a previous lecture use of the Laplace transformation in a numerical problem. Now I am discussing Laplace error function. It means error function of Laplace transformation. Error function, error function of Laplace transformation is stand for error function of t is equal to 2 upon root pi integration 0 to t e to the power minus x square into dx, or simply your written this error function of root t is equal to 2 upon root pi integration 0 to root t e to the power minus x square into dx. This is a error function of Laplace transformation. Proof. And what is the value of error function of root t? Now applying Laplace transformation, you can know L, error function of root t is equal to L 2 upon root pi integration 0 to root t e to the power minus x square into dx. Now you can solve this Laplace. You can note down L, error function of root t is equal to L 2 upon root pi integration 0 to root t e to the power minus x square into dx. Now you can solve this integration, because you know that e to the power x we know that e to the power x is equal to 1 plus x square upon factorial 2 plus dot dot plus x to the power n upon factorial n. Now putting the value of exponential e to the power minus x square, we have L 2 upon root pi integration 0 to root t 1 minus x square plus x to the power 4 upon factorial 2 minus x to the power 6 upon factorial 3 plus dot dot into dx, into dx. Now solve this Laplace L integral. Now putting the integration of this function 2 upon root pi bracket integration of 1 is x minus x cube upon 3 plus x to the power 5 upon factorial 2 5 ja 10 minus x to the power 7 इंटू फैक्टोरियल 3 की वैल्यू आपकी होगी 6 6 इंटू 7 इज इक्वल टू 42 प्लस डॉट डॉट लिमिट 0 टू रूट t. Now you apply L 2 upon root pi. Now putting the value of limit 0 to t. Now limit of root t यानी t to the power 1 by 2 minus t to the power यानी it means t to the power 3 by 2 by 3 plus t to the power 5 by 2 upon 10 minus t to the power 7 by 2 upon 42 plus dot dot. Now using the Laplace of this function 2 upon root pi t to the power 1 by 2 Laplace of t to the power n is equal to gamma n plus 1, this means 3 by 2 upon s to the power 3 by 2 minus this function gamma 5 by 2 upon 3 into s to the power 5 by 2 plus gamma 7 by 2 total upon 10 s to the power 7 by 2 minus dot dot this. Now you solve this. If I have common both equation s to the power 3 by 2 and open the value of gamma, since gamma n is equal to n gamma n minus 1 and gamma 1 by 2 is equal to root pi. You know that also. Now you know that gamma n is equal to n gamma n minus 1 into gamma 1 by 2 is equal to root pi. Again this step you note down 2 upon root pi bracket. Now you can also common s to the power 3 by 2. Now open gamma 3 by 2, it means 1 by 2 gamma 1 by 2 total upon s to the power 3 by 2. Now minus open the gamma 5, open gamma 5 3 by 2 into 1 by 2 into gamma 1 by 2 total upon 3 into s to the power 5 by 2, s to the power 5 by 2. Now plus open gamma 7 by 2 5 by 2 into 3 by 2 into 1 by 2 gamma 1 by 2 total upon 10 into s to the power 7 by 2 minus dot 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 remaining this function. Now you can comma gamma root pi, this means gamma 1 by 2 into 2 into root pi into also common 1 by 2 into gamma by 2, 1 by 2 into 1 by gamma 1 by 2 total upon s to the power 3 by 2. Now you can remaining the bracket 1 minus, now 3 will be cancelable, 1 by 3, this means also written plus minus 1 by 2, now remaining 1 upon s, now plus minus 3 by 2, now this is cancelable, minus 1 by 2, now 1 upon s square plus this. Now you can solve this putting the value of gamma 1 by 2 is equal to root pi. This means cancelable. 1 by 2, 1 by 2 is also cancelable. Now you have remaining s to the power 3 by 2 bracket 1 plus minus 1 by 2 1 by s plus minus 3 by 2 minus 1 by 2 1 by s square plus this. This is a function of 1 upon s to the power 3 by 2 1 plus 1 by s to the whole power minus 1 by 2. You can solve this function. Laplace of error function root t is equal to, you can solve s to the power 1 by 2. Now numerator is opposite to denominator is opposite to numerator, since minus 1 by 2 is a power. Now s into s to the power 1 by 2, now s plus 1 to the power 1 by 2. Now you can write this 1 by s under root s plus 1. This is a error function of Laplace transformation. Hence prove that Laplace error function of root t is equal to 1 upon s under root s plus 1. You can note down this lecture. This is very important for your examination, and you also find the numerical problem of this resultant. This is a conclusion of a error function. Now you can use in a numerical, so you can note down this function. Some important conclusions of error function. Error function. We know that Laplace error function of root t is equal to 1 by s under root s square plus 1. Now L error function of a under root t, it means Laplace error function of t a square. Now putting the value of this function means, it means 1 by a square into 1 by s upon a square under root s upon a square plus 1. Now you can solve this. A square will be cancelable. Now a upon under root, now sorry, s a upon s into s plus a square. This is a Laplace error function of a under root t. This is an important conclusion of error function. This is an important conclusion of error function. Now I am discussing complementary error function. Complementary error function. It is defined as Laplace error function of t complementary Laplace complementary function of t is equal to Laplace of 1 minus error function of t, where error function of t is equal to 2 upon root pi 0 to t e to the power minus x square into dx. Now we know that Laplace of error function root t is equal to 1 upon s under root s plus 1. Now the complementary function of Laplace and Laplace error function, complementary error function of root t is equal to Laplace 1 minus error function of root t. Now putting the value of error function of root t, it means Laplace of 1 minus Laplace of error function of root t. Now you can solve this. Laplace of 1 is equal to 1 by s minus, you can solve this, 1 upon s under root s plus 1. You can solve this. It means root s plus 1 minus 1 total upon s under root s plus 1. Now you can use complementary and Denando theorem. Now you can written this s plus 1 minus 1 bracket root s plus 1 plus 1 total upon s under root s plus 1 bracket root s plus 1 plus 1. Now you can solve this. It means s upon s under root s plus 1 s plus 1 plus 1. Now you can write this Laplace of complementary error function of root t is equal to 1 upon root s plus 1 bracket root s plus 1 or plus 1. This is the important conclusion of complementary function. Now you can write this and note down your notes. This is a complementary function of Laplace transformation, and this is a very important conclusion of Laplace transformation if A is also putting. You can note down. Thank you.